Welcome to this puzzle session. Here is the problem. Each point of the plane is colored either red or blue. So we have this entire Euclidean plane infinitely extending in all directions. So every point of that has been assigned a color, either red or blue. We want to show that there exists a rectangle such that all of the four vertices of the rectangle receive the same color. So no matter how chaotically or intelligently you color the plane with two colors, you cannot avoid this pattern. You will always find a rectangle, a non-degenerate rectangle. We are not talking about, things like this. One call that also a rectangle with zero width or something, but no, a proper rectangle with all four of its vertices of the same color. Okay. As usual, you're encouraged to pause the video and try to find a proof for yourself before we look at what we discuss. And with that, now let us move on. So actually, the hypothesis is very, very strong. We do not need anywhere near the entire plane for this. I have drawn something here. Let me explain. So I have drawn a 9 cross 3 rectangle. I've conveniently just chosen this to be 1 unit. So it's a 9 cross 3 rectangle. Let me count. 1, 2, 3, 4, 5, 6, 7, 8, 9. All right, yeah. And just focus on these vertical lines for the moment. And in fact, not on the vertical line, just on the 3 points. So let's focus on this one for the moment. Now, it receives some color pattern. So these 3 points, this receives either red or blue, either red or blue, either red or blue. So any of these segments, and by segment again, I just mean the 3 points. What is the color pattern that it can receive? It can receive one of red, blue for the top vertex, one of red or blue for the middle vertex, and one of red and blue for the bottom vertex. So there are a total of 2 into 2 into 2, 8 possibilities. So there are 8 possible color patterns that one can detect here, same for here, and so on. But there are 9 segments and only 8 color patterns. So there must be 2 different segments which witness exactly the same color pattern. Okay, let's say for concreteness that those 2 segments are this one and that one, let's say. They see exactly the same color pattern. Now let's focus on this. Let's focus on this segment. Since there are 3 points and only 2 colors that appear on these 3 points, 2 of these colors must be the same. This is an invocation of the pigeonhole principle, but this is just pure common sense. If you have 3 points and you're coloring them, each of them with either red or blue, you're bound to repeat the usage of one color. So 2 of these 3 points receive the same color. It's possible that all of the 3 receive the same color, but at least 2 of them receive the same color. And not this one, I meant that one. That is true for any segment anyway. So I was actually focusing on this one. So there are 2 points amongst these 3 which receive the same color. For concreteness, let's say these 2 receive the same color, and for further concreteness, let us say that color was red. Okay, but as we had already seen, the color pattern that appears here is the same color pattern that appears here. So this must also be red and this must also be red. And we have located a rectangle whose all 4 vertices receive the same color. In our argument, it is red, but it could have been blue. So we just, for concreteness, called it red. Okay, so I hope this was interesting. As usual, like, comment, share, subscribe, and I will see you next time. All right.